Hello and welcome to Understanding APIs. This is a course where we're going to learn all about APIs. So the first thing we need to know is, what is an API? Well, an API is an application programming interface. It's not actually a visual interface like what you see in front of you. No, it's nothing like that. It is a programming interface. So it's sort of visual. If you were a computer, it would seem visual, but we're not, so we can't see it, and it just looks like a wall of code. But essentially, all it is one computer talking to another. That's it. It's very, very simple, and it doesn't matter what programming language you're using. You can use JavaScript, Python, PHP, Java, Ruby, any variation of C. Basically, any language that supports internet communication will support APIs and RESTful APIs, and there is a difference. We'll talk about those in just a little bit. So there are many different forms of API, but RESTful APIs are the most common API these days, and that's the API that we are going to be talking about primarily, because RESTful APIs are so popular, and there's a reason they're so popular. It's so simple, and that's what we're going to be learning about in this course. So I'm going to be using an analogy. I'm going to be using the analogy of a restaurant. And you're going to have you're going to have a waiter, and you're going to have a chef in your kitchen. So you're going to have three primary people in this scenario, and this is going to span the entire course. So it's good to be familiar with a restaurant analogy. So you can think of your API as sort of like your waiter. Your waiter is your messenger. So your waiter comes up to you and says, "Good evening, sir. What can I get for you?" And you say, "I would like your finest pizza." I don't know why I sound like Marvin the Martian, but I guess that's my voice as a pizza orderer. And then basically your waiter says, "Yeah, okay, I will get you that pizza, and I will just basically go and tell that guy just over there, he's the guy who's gonna make you your pizza. He's the chef. I'm gonna take your request and I'm gonna give it to him. He's gonna do really all the magic behind the scenes, and I'm just going to be the person who helps you out with the different requests." So you order a pizza, and your messenger, your waiter, goes to the kitchen and says, "Hey Tony, we have a customer at table number 1 who wants a pizza." And the chef starts making you a pizza. And when it's done, your waiter then brings food to you in the form of pizza, and you get to consume that pizza in any way, shape, or form. You want to use your hands, you want to use utensils, maybe you just want to like poof, put your head right into the pizza and just smear your face around in it. Doesn't matter, it's up to you. You got the pizza, you paid for it, it's yours. It is really that simple. So when people talk about APIs, don't get overwhelmed. Don't think that it's this huge thing on the internet that's really, really hard to understand, because really all an API is the ability for one computer or one software to talk to another computer. Because really all it is the ability for one software over here to talk to another software over here. Or maybe it's two different computers over an Ethernet connection, maybe it's two computers over a cable connection, internet connection, who knows? It's two systems of some variety talking to each other. That's all it is. It's no different than me picking up the phone, calling you, you picking up your phone, and us having a conversation. It's it. That's it. That's all it is. Now, RESTful APIs are a type of API. They're meant to be incredibly simple. So let's take a real life example of what an API looks like. So this is a site that uses an API to collect flight prices from different websites. So we're going to be using a service called Skyscanner. This is a real service. Unfortunately, no, they did not pay me to use their name. Skyscanner is one website. You go there, you type in your destination, your departure time, your arrival time. It will take all of your data, bundle it up, and it will say, "Go out, my minions, and find all this different data." And basically it's going to take your data, send it off in 30 different directions, and it's going to ask airline websites for their data. Now, Skyscanner does not hold all of this data internally. It would be pretty impossible for them to constantly update all of their systems. Well, maybe not impossible, but definitely not worth their effort. All they want to do is create a nice single list for you. 1, 2, 3, 4, 5, your top 5 choices for flights based on convenience, maybe maybe based on price. Maybe you want the cheapest possible flight. Who knows? But Skyscanner is going to get all these different connections and put them all in one place for you. So basically, Skyscanner sends out a request to all these different computers, and you can see here they are, these different computers outside of our Skyscanner website. And basically, this is an API request. Skyscanner is going to every single one. It says, I need a response from here, I want the data from here, I want flight prices from here, and here, and here, and here, and here, and so on, and so on. So once it makes that request to all these different servers, it waits a little bit, waits for all these different servers to basically say, yep, here's my data, and here's my data, and here's my data, and here's my data. And it just waits for all of them to come back, and then gives you a nice list. And in that list, it looks like Skyscanner is doing all the work. But really, Skyscanner just sent off data to all these different services, and these services came back with data, and Skyscanner simply presented it to you. That's all it did. That's the power of an API. Now that's a fairly extreme example because that is a one-to-many. That is one service using many different APIs and bringing them all together under one house. Or a lot of APIs or the other way, where, for example, you may have one of these computer nodes, maybe this is Air Canada, and you have Skyscanner and Kayak and all these other different services accessing their data. So now all of a sudden you have this massive network of computers all talking to each other. So computers use APIs to talk to each other over the internet. Now that's somewhat factually incorrect. It doesn't have to be over the internet. They can talk to each other over different services, different softwares. It can be basically you plug your MacBook into your Windows computer, and if there's a software in the middle that can join them, that might be considered an API. It's not considered a RESTful API, but that would be considered some sort of API integration or interface. So let's take a look at what programming languages we can use. So we see this image here and it says PHP, C++, JavaScript, Ruby, Python. You can put in, Java if you wanted to. You put in all sorts of different languages. There's one bad guy in here who doesn't belong. That guy right there. HTML does not belong. Now, HTML does not belong because it is a markup. It is not a proper language. All it does is make your website look nice. It does nothing else. So just as a quick little list, here are some of the languages, most popular languages in the world that we can use for APIs. Basically, any sort of language you can use to make a website, you can use for APIs. Python, JavaScript, PHP, Java, C, Ruby, etc., etc. If you're making a website with it, maybe it's .NET, you can use APIs. So let's take a look at what a RESTful API is. REST is a type of API and it stands for Representational State Transfer, which sounds overly complicated because that's what us people in computer engineering, computer science do. We make things sound harder than they actually are. But simply put is a client computer, so I should explain this one. A client computer is any computer that is making a request to the server. So if you're sitting at your restaurant table and your waiter is way over there, you are the client and your waiter and the chef would be, well, actually just the chef really. The chef would be your server or the computer that you're asking data from. Now, simply put, an API is a client computer asking another computer for data or maybe to take a particular action to modify data, delete data, create data, something like that. So let's take a look at Swappy, the Star Wars API. So I just loaded up my browser here. I'm at swappy.co, and all this is a free Star Wars API where you can get all sorts of Star Wars data for free. Now, an API request, well, this is where we're going to learn the basics of an API request. So if I scroll down here, we have swappy.co/API, and it just says people/1 or planet/3 or starship/9. And on the surface, that makes no sense. But let's dig into this a little bit. So if I click, let's click planets/3, and it's going to make an API request to this particular service. So it's saying, hey, waiter, I would like to see planet number 3. The waiter is then going to say, okay, I will get you a menu of all the planets. Specifically, he opens it up for you and says, here is number 3. Turns out that number 3 is Yavin 4. Its climate is temperate, it's tropical. Diameter, I'm not even sure what 10,200 is, meters, kilometers, who knows. The date that it was created, its actual URL as well. We can do the same thing with Starship. Starship number 9, let's ask what that is. We say, hey, Mr. Waiter, in this case, it is swappy.co. We want to say, hey, Swappy, what is Starship number 9? So your waiter says, okay, let me get you the menu for all the different starships, brings it to you, opens it up, and says, number 9 is the Death Star. And so generally, an API will then spit out a bunch of data that looks like this. Now, if you're not familiar with this, that's okay. This is called JavaScript Object Notation, or JSON for short. Now, what JSON is a structured key value pair. So you have a key here. The name is the Death Star. The model of the Death Star is the DS-1 Orbital Battle Station. The Starship class is a Deep Space Mobile Battle Station. And basically, when you make a request to a service like this, it's just going to give you all of this data in here, and you can do whatever you like with it. Now let's take a look at a real example. So I'm going to inspect my element, hit the console. Let's make that just a wee bit bigger. And I already have this in my clipboard. This is just a JavaScript example of using the fetch API, where I'm going to simply go to swappy.co/API/people. This is then going to basically say this is a JSON response, so make sure it's JSON, and console log whatever the response is. Now, if you don't write JavaScript, that's okay. You can do this in basically any language. It's going to look a little bit different. Your syntax, your functions are going to be called different things, but basically this is it. This is the simplest form. So let's go ahead and hit enter. So it created a JavaScript promise and returned an object. Now this object has a count of 87. There's a next URL, so there's more than one page. That's pretty cool. And not all APIs will give you a next or previous or a count, but this particular one does. And in here there are 10 results. So of these people, we have Luke Skywalker is number 1. Let's just close that. We have Luke Skywalker is number 1, C-3PO, R2-D2, Darth Vader, Leia, Owen, a bunch of other people in there. Okay, so we have a bunch of other people. Now, we said specifically to go to swappy.co/API/people. Well, we're not there. We're at starships/9. So let's go ahead and type in API/people. And because we didn't give it an exact person, and I'm just going to put that example back in there because that went away. Because we didn't say we want person number 1, we want person number 5, we just want all the people, it's going to give us a list of all the people. And so we can see here Luke Skywalker is number 1, C-3PO is number 2, and that's going to match our JavaScript object notation down here in our results. Where are you? Let me just make that a little bit bigger. Where is your name? Luke Skywalker. There you are. Key is name. Value is Luke Skywalker. And that's number 1. So if I scroll up here to number 1, key is name. Value is Luke Skywalker. And so this is the exact same as saying, excuse me, Mr. Waiter, can I get the menu? And if you're at a place that has a really large menu, and maybe you just want a particular menu, because they have different types of menus. So the waiter says, yeah, I can get you a menu, and you can see everything on it, but we also have a more specialized menu for just spaghettis. So maybe you want to see just spaghettis, or in this case, you just want to see a particular person. So let's go ahead and type swappy.co/API/people, and let's put in a random number. We know that there's 87 in there, the total count of 87. So let's see who number 83 is. Number 3 is Tion. I have no idea if I'm saying that right, but that's who this is. Eye color is black. He's in film number 6, whatever film that is. We could click this URL and we can see it. And the film is Revenge of the Sith. And so really this is just a GET request. Now we're going to talk more about GET requests and how these actually work, but basically what you need to know is the standard RESTful API will return a response that looks something like this JavaScript object notation. And this JavaScript object notation is pretty standard across most RESTful APIs, but it's also standard across pretty much every programming language. So hello JSON, welcome to our world. Again, you were called JavaScript object notation. Now, again, most languages have a data structure that looks something like JavaScript object notation, where you have objects and you have arrays, and it's a key value pair. They look very, very similar across most languages. So one day, some guy said, JavaScript object notation should be a standard. So he made a website and the internet said, wow, this is good. Okay, we agree. And boom, just like that, JSON was born. Now let's talk about HTTP requests. We've already looked at a lot of GET requests, and that's the first one we're going to explore here. So let's take a look at how they work sort of behind the scenes using our restaurant metaphor. A GET request is, you know, when you go onto your laptop or your phone and you type in www.facebook.com, and your browser is basically saying, okay, well, I know you want to get data. You're not asking to send a request to change your profile data or anything like that. You're simply saying, I just want to see facebook.com. So your browser is your waiter, and you say, excuse me, Mr. Waiter, I would like to see facebook.com. The waiter, your browser, goes over there, talks to your chef in this case is Facebook, and your waiter says, excuse me, Mr. Chef, Facebook, this person over here at table number 1 would like to see whatever you have. And the chef in the basic GET request example basically says, yes, okay, I will make user at table number 1 the finest plate of HTML, CSS, and JavaScript. And so it does a bunch of tinkering over there and comes back and then says, oh, waiter, browser, your response, your meal is done, and the waiter then brings it back to you. Over here, your browser, your waiter, will then make a nice sort of presentation out of all the HTML, CSS, and JavaScript. Now a GET request really is you saying to another computer, hey, excuse me, I would like to make a request to see some more data. I just want to see data. I don't want to do anything to it. I just want to see it. Now, again, you're not asking a server to update or delete or create any sort of resources or update your profile or anything like that. You just simply want to load the page first. You want to load the website. And this is the most common request type. It's actually so common there's probably trillions of GET requests per day. In fact, you actually probably made, I'm just guessing, but probably 15 or more GET requests just to watch this video. Now, if you're watching a video on YouTube with that adaptive bitrate where, you know, sometimes your quality gets really good or really bad, like what Netflix does, you're making GET requests every 15 seconds or more. And so you have all these GET requests all the time. You don't even know they're happening. Now let's make a table. We have a table called HTTP methods for RESTful requests, and on the left we have HTTP methods, and in the center we have CRUD operations. That is your create, read, update, and delete operations. And on the right we have example URLs. So on the left we have our GET request. That's what we're talking about. And its CRUD operation is read. All it does is read. It's the exact same thing as saying, excuse me, waiter, can I see your menu? Waiter comes up to you and says, boom, here's your menu. Feel free to look at it. Now, an example URL is, for example, website.com/API/users. And if you go here, it's going to list you all the users. This is called a list view. And if you just want to see a particular user, maybe user number 1, because we're sitting at table number 1, you would type in /API/user/1, and that will tell the API, I want not just all the users, I want one particular user, and that's it. Okay, let's take a look at post requests. How do post requests work? What are they? Let's dive into this. And after this example, this is really going to start making a lot more sense to you, I think. So a post request does not go through the URL. It's not a standard URL, but it does take a URL as an endpoint. That in itself is confusing. Now, what I mean by that is you cannot go to post.facebook.com and just make a new post. It doesn't work that way. You still have to go to www.facebook.com, and then behind the scenes, you can make a post request. And a post request does not go through your URL bar, so you can't access it through a standard browser URL. You can't just type it in. You actually need some code to do this. But really, a post request, all it's doing is saying, hey, I would like to make a brand new resource. And ideally, it will return all of the sort of unique identifiers for that resource, so then you can perform a GET request. An example of this is when you want to create a brand new user, maybe you're signing up for Facebook. You want to create a new user, so you put in your first name, your last name, your email address, your date of birth, and your password. And you hit submit. And that goes off to Facebook. Facebook says, yes, that is a post request. I'm going to create a brand new user. And with that brand new user, Boom, everything is good. I'm then going to give you a user ID. Now, when we add this to our table, the post request is the create method in our CRUD operation. And an example of this is using it on the entire resource itself. So you would not do a post request on website.com/API/user/1 because you would be trying to create a user on user 1. Users don't typically have sub-users. In this example, you would be using just /users. That would be your endpoint, your resource URL, your URI, sometimes it's called. And you're going to create a new user and basically add it to the list of users. Now in our restaurant metaphor, the post request is basically, excuse me, waiter, I would like to see the menu. He brings you your menu, you take a look at it and you say, I want the pizza. And so you say, excuse me, waiter, hi, yep, could I order the pizza? And he says, absolutely, you can order the pizza. He takes your request, he sends it over to that guy over there, he's the chef. The chef then says, okay, I acknowledge that this person wants a pizza, I will make a pizza. 20 minutes later, there's a pizza made, and he sends it back to the messenger. The messenger then says, thank you, chef, for making me the pizza. I will deliver it to the user, to the person sitting at the table. Basically, the chef created something for you. You made a post request to the chef. That's a good way of thinking about it. Okie dokie, let's take a look at delete requests. You have an idea of what get and post requests are. Delete is wow, that's a pretty well-named request. What else is it going to possibly do? So a delete request, again, does not go through the URL, so you can't type delete.facebook.com and assume Facebook is deleted. It doesn't work that way. You have to use some code and you have to give it a specific endpoint. And what this is doing is you're saying, computer over here, make a delete request to computer over here, and all I want to do is delete a resource. And that's all it does. So maybe you want to delete a particular user. Maybe you want to delete a credit card off of your Amazon account. Maybe you want to delete an image off of a Facebook gallery, or maybe you want to delete a tweet or an Instagram post. Who knows what you want to delete? But that is the request that you would use. The request method would be delete. Now, use with caution. When you're implementing an API, if you allow people to delete entire lists, that could be bad. So if someone said, yeah, I want to go to website.com/API/users with a delete request method, that could possibly delete all of your users and you might not get that back. So use delete with caution. Only ever implement it when you need to implement it. Now let's add delete to our table. At the bottom here, we have delete. Its CRUD method is delete. And to delete, you would give it a specific endpoint. So don't give it a listing URL such as /users. You want to give it a specific URL such as user number 1 if you wanted to delete user number 1. Now in our ongoing restaurant example, what this sort of translates into is when you're done eating, your waiter will then bring you the bill. And you look at your bill and you open it up and you say, yep, that's mine, that's mine, that's mine. All the prices look right. But then you get to this one down here and you say, oh, I was charged twice for the pizza. And I should only have been charged once. I only ordered the one pizza. Why am I being charged twice? So you say, excuse me, Mr. Waiter. Yeah, there's something wrong on my bill. I was only eating the one pizza, but I was charged twice. So the waiter then says, okay, I will put in a delete request to delete that one line so you're only charged the one pizza. All right, let's take a look at put and patch requests. How do these work? These are the last ones we're going to take a look at in this course, and they are somewhat similar and they're sort of bundled together for a reason. So a patch request, again, does not go through the URL, so patch.google.com is not going to give Google an eye patch or do anything. All a patch request does is it asks another computer or another piece of software to update a piece of a resource, not the entire thing. So don't update the entire user account, just update maybe the first name. Now, there's a caveat with this one. The caveat is that not all browsers support patch requests and not all frameworks support patch requests. For example, Internet Explorer 7 would not support patch requests. And Django framework, a Python-based framework, does not support patch requests as far as I know, so instead you would use a put request, which is what we're going to talk about in just a moment. Now in our analogy, where we're sort of working with the bill at the end of our meal, this is sort of like getting your bill, you open it up, you look down, you say, you've got a drink, you got a salad, you got a pizza, and you were mischarged for your pizza. It's the right pizza, you got your whatever type of pizza you like to eat, but instead of being charged $14, you were charged $15.95. Don't know why, but you just want to update a little piece of that resource. You don't want to get rid of the pizza line in your receipt or in your bill at all. You want to just get rid of that one price and update it. So you would say, excuse me, Mr. Waiter, yeah, this price is not right. The pizza is right. That's exactly what I got, but the price just isn't quite right. Could you update that for me? And so that's like updating a small piece of your bill. Now your put request does not go through the standard URL, and you cannot go to put.facebook.com. It doesn't work like that. The only one that does work like that is your GET request, and you don't put get.facebook.com, you just type in your URL and your browser assumes it's a GET request. Now a put request is going to ask a computer to update an entire resource. Now going back to our bill analogy, we take a look at our bill, at our check, and we have our drink, we have a salad, and we have a steak on there. But we didn't order a steak, so something got messed up somewhere, and we need to completely update that resource. That steak needs to actually be a pizza, and that pizza needs to cost $14. So we say, excuse me, Mr. Waiter, can you go tell whoever you need to tell that this is actually wrong? We didn't order a steak, we ordered a pizza. And the waiter says, yep, okay, that makes total sense. I am going to update that for you. And then he comes back and you look at your bill and everything's right. There's a pizza on there for $14 and there's no steak. You've updated an entire resource. Now some APIs, and this is sort of a caveat, but some APIs, if a resource does not exist in a put request, it will make it exist. So it's sort of like sending a post request as well. It's sort of a two-in-one kind of deal here. Not all APIs do this, but some of them will. Now taking a look at our table here, we have put and we have patch. Now, put is basically your update and replace, and patch is like a partial update, partial replace. But because patch is often not supported in a lot of different areas, we sort of just rely on put instead. Although if you do see patch, don't be freaked out, it is okay. And to put a resource, or to update or to replace a resource, you give it a specific URL, not a listing URL, so not just /users. If you want to update, it would be /user/1 to update a user. And if you're using a patch, it might even be more specific. You might have an endpoint that looks like website.com/API/user/1/first name. And that's all you do is you just update the first name. Now I've got a note down here that says you can find more details at restfulapi.net/http-methods. I'll give you that link at the end of this course as well. Okay, let's take a look at consuming APIs. Now an API can be written in almost any server-side language. It doesn't really matter what the language is. It can be written in any language as long as that language can accept HTTP protocol requests. So get, put, post, patch, delete, anything like that. And APIs will generally return one of two data structures, either JSON or XML. Now we've already seen JSON and we can see it here on the left where we have key value pairs. So we've got a key on the left and a value on the right. And in the right side of this slide, we can see an XML example. And basically it'll give you the exact same stuff, it just looks different. XML is sort of the old way of doing it. It has a larger payload, not that it really matters with fast internet speeds these days. But JSON is a little bit more verbose. It looks a little more lightweight. The nice thing about XML, though, is it does come with a contract. And a contract generally means that nested second field, for example, should always be an integer. And in JSON, you don't really get that. In JSON, key val example, well, right now it's value, so that's a string in programming languages. But maybe it's supposed to be a number. Maybe it's supposed to be an integer. Maybe it's supposed to be true or false. Those are different things to programming languages. And there's no way to really make sure that it is what it is. And so XML comes with this idea of contracts and JSON does not. So JSON is a little more lightweight. Now an API can be consumed in just about any language, as long as it's a proper web language that's, somewhat web enabled. But largely you're going to be using JavaScript on the browser side for front-end requests, like what we did in our example with the swappy.co API. And servers can use pretty much any language that run on a computer because, well, it's like Python talking to a Python server, or Java talking to a Python server, or Python talking to, I don't know, a C server. It doesn't really matter as long as it can spit out some sort of language that's in the middle. And for us, that's JSON. JSON is that nice middle ground. So it doesn't matter if you're writing Python or JavaScript or Java or C or anything like that. All that matters is that whatever is returned to you is readable in your programming language. Okay, so let's take a look at some common API responses. What are they? Before we do that, let's take a look at requests and responses. I keep saying requests and responses, and by now, if you haven't decided to just go off and Google it on your own, I'll tell you exactly what they are. So a request is like when you say, hey, Mr. Waiter, sorry, can I have your attention real quick? I need something. That's a request. You're requesting something from him. And a response is like, hey, Mr. Waiter, I would like to order a pizza. The waiter goes to that guy over there, goes to the chef, and the chef says, yes, I will make you a pizza. Wait a couple minutes, and I will make it for you, and you can send it off to the customer. So the chef makes a pizza and says, ding, waiter, this is done. The waiter then comes and brings it to you. That is a response. The chef has responded to your request with a pizza. Now, all requests come in the form of either get, put, post, patch, or delete. There are a few other ones that we're not going to cover, but these are the main 5, almost main 4 really, if we don't really include patch because it's not totally supported. So those are the main ones you're generally going to run into, and the server response is going to give you some sort of HTTP status code. And that brings us to HTTP status codes. So this is basically what the server is going to tell you. It's a number, and this number is going to tell you if something is right or wrong and sort of give you an idea of what is right or what is wrong. So let's look at some common HTTP status codes. A healthy response is in the 200 range. So we typically have 3 of them that we deal with. We have a 200, okay, that basically means your request was good, everything looks fine, and you have data returned. A 201 is a created request. Now this generally comes back from a post request, and that's the server saying, yep, everything was good, and we also made the resource for you. So here's a 201. And a 202 means it was accepted, but the server's busy. So this is sort of like saying, excuse me, waiter, I would like to order. Your waiter then takes your order, goes to the kitchen. The chef says, oh, I'm really sorry. I'm really backed up. I have 3 meals I got to make before this one right now. This is number 4. So once I get through the first 3, you're number 4. But could you tell the customer that's going to be a couple minutes and maybe send my apologies? And so this is a 202, accepted. This is your waiter saying, yep, your request was accepted, but your food's going to take a little bit of time to get to you. Next, we have redirect responses. This is the 300 series. Again, there are a ton of these, but the most common 2 you will run into are 301 and 302. 301 is moved permanently. This is basically when you try to access an endpoint and it's gone. It's gone, it's moved to a different place. And maybe that redirect happens for you, or maybe you get a different error that basically says, there's a 301 in here and the text response is, the endpoint has moved to somewhere else. And a 302 is found. That means the endpoint that you're accessing is temporarily moved to somewhere else. So it does exist, but it's sort of like when you're driving somewhere and there's a lot of construction and the road is actually closed. So you sort of have to just go around. Next, we have a 400 response. Actually, we've got a whole series of these. Again, there's a lot more of these, but these are the most common 5. So the first one is a 400 request. Now, these are client responses. This means that something on your end is not right, and the server is telling you that something on your end is not right. So the server in a 400 response cannot or will not process your request. Maybe you have bad API keys. Maybe it thinks that something is wrong. Maybe for whatever reason, it just thinks that the text that you sent isn't right. Maybe you have a typo in there. Who knows? But it's saying that there's something wrong in there. A 401, is unauthorized. Now, this is basically saying, and this is the most common situation when you get a 401, it's basically saying you're not allowed to be here. So this is like you going directly into the kitchen and asking the chef to make you a pizza when you should be going through your waiter. You're not allowed to be there. You don't have the right credentials, so you have to go through the right channels. A 403, forbidden, basically means the server understands your request, but it's not going to execute it. Basically, your API keys probably don't have the right permissions associated with it, or in our restaurant analogy, that's like going directly to the kitchen again and the chef just being like, no, you can't be here. I can't talk to you. You're not allowed to be here. This area is forbidden to customers. Get out. You have to go through someone else. A 404 is basically there's nothing there. Nothing there at all. So you probably have a typo in an endpoint, or maybe they moved something and didn't tell you. 404 in our analogy is like going up to the kitchen and realizing that there's nothing there. It's just an empty room. There's no kitchen stuff in there at all. It's just a door that looks like there could be a kitchen in there, but there's nothing. And a 405 is method not allowed. Now this is a very common one as well, where maybe you're trying to do a post request. So let's say you want to get details about a particular user, and you copy and paste some code, and it was working before, but now it's not, and that's because you're using a post request. But you just actually want to get data. You're not sending data to the server. You're not asking it to update. All you're doing is saying, I just want to see some data, but you accidentally send a post request. A 405, method not allowed, is saying, oh, you have the right endpoint. Things look like they could be right, but you didn't send the right request type. So maybe change it from post to get, or change it from put to delete. I don't know what it's going to be. It depends on your endpoint. But basically it's saying your request method is incorrect. Lastly, we have server responses. These are your 500 statuses. And actually there's really only one that you'll generally run into, and this one is an internal server error. And this is the only one where if you ever get this, this is not on you. If you don't control the server, there's nothing you can do about it. So if you get a 500 status from Facebook or Google or Twitter or Instagram or anyone else, that means something on their end is wrong. You didn't do anything to break it. They did. And there's nothing you can do about it. This is probably the worst one because you are absolutely out of control. Now, just for fun, at the end of the status code lesson, I would like you at the end of this video to basically just hop onto Google and type in what is a 418 HTTP status response or a status code. I think you're going to like it. This one gives me a little bit of a chuckle. I don't know why it's there, to be honest, but the internet is full of fun little Easter eggs like this, and I think you're going to get a little bit of a chuckle from it as well. Once you're done that, head on over to that next lesson. I'll meet you over there. Okay, lastly, let's talk about API security. API keys are basically your passwords. It's like logging into a website with your username or your email address and your password. API keys are your authentication credentials. Basically, every website requires API keys, and Facebook's Graph API is a good example. So if you were to go to graph.facebook.com/coding4everybody, you will see something like this, where it says an access token is required to request this resource. Now, we haven't talked about access tokens, but an access token is generally created with an API key. So it's like an API key for an API key. Along with that, if we look at the bottom here, we can see that the status code is a 400. It's a bad request. It means there's something missing. Now, not all services will give you a 400. Facebook gives you a 400, but some other services might give you a 403 or a 405 status. If you don't remember what those are, quickly hop on the Google and just type in what is a 403 or what is a 405.